Hi everyone. So today we're going to start talking about cost minimization, right? So there are very important goals for firms. There's one where we want to focus on profit maximization, and at the same time we also want to make sure that the cost for our inputs is not too expensive. So cost minimization and profit maximization. Now we're going to focus on cost min. If there's one thing that we really want to get from this is this whole idea of bang for your buck. Like the last dollar rule is very important, right? So that really just means when you're picking the inputs, where the last dollar that you spend on one input gives you as much happiness or as much utility as the last dollar that you spend on any other input, right? So the last dollar spent on one input, we're gonna assume maybe it's just labor or something, gives us as much extra output as the last dollar spent on any other input. So maybe that could be something like capital or something, right? And so that is really the concept of bang for your buck. You can you can also replace this with the as much extra output with utility, actually, right? So is an extra pair of glasses giving me the same amount of utility as an extra pair of shoes? Is it giving me the same amount of utility, benefit, pleasure, something like that? So to kind of define that, like bang for your buck, another way of writing it is really just the marginal utility of our X over the price of X has to be equal to the marginal utility of Y over the price of Y. So this entire equation is very important when we're trying to solve our problems, which you'll see in the next video. Wanting to make sure that these are equal. A lot of times this is not equal, and that's when our firms have to focus on, okay, which input should we really focus on? Which input should we really spend time creating and focusing on so that we can get the most out of our output, so that we can get the lowest cost and the highest profits. So that's how it really works. So really another way of writing this, to minimize the cost of producing levels of an output, the firm basically chooses inputs so that the MRS, the marginal rate of technical substitution, so I can write this out maybe, marginal rate of technical substitution. This has to be equal to the relative input prices, right? So that's the W over R. So actually this entire thing is pretty much the same thing as this. You're just rearranging with cross multiplication and all of that, and you should get this equation. And if you've seen from previous videos, we should already know that MRS is actually the same as the marginal product of labor over the marginal product of capital, right? And that is where this comes from. And so we just equate those two. We'll get marginal product of labor over capital over marginal product of capital is equal to W over R. And if you again rearrange this, you should get the same thing as this little formula, and it would just be MPL over W is equal to MPK over R. And this is probably the most important equation when you're trying to solve these cost minimization problems, right? If the inputs are chosen so that the last dollar spent on labor adds the same amount of output or the same amount of utility as the last dollar spent on capital, then we know for sure that our cost is minimized. Oops, sorry. All right, so now we're going to take a look at a graph where capital is on the y-axis and labor is on the x-axis, and we're going to just kind of differentiate between the two different points, like two extremes, point A and point B. Here we can see, obviously, that point A is a lot steeper, right? We have a slope that looks like it's greater than 1, right? And then this one is a lot flatter. So maybe let's just point that out, right? Here, I'm using a new word. It's isoquant. Isoquant really just shows us that it is just the marginal rate of technical substitution. And the slope of the isoquant will really just give us the trade-off between the abilities of labor versus capital. The abilities between labor and capital here. So here, we know that the isoquant for A is steep. And here we know that the isoquant is flat. Ooh. Sorry about that. Flat. Now, what does that tell us about, our slopes? What does that tell us? Or what does that tell us about our firm, right? We can reduce a lot more capital, right? A lot of capital. If we go from, let's say point here to point here, when we're going there, we can reduce a lot more capital and only increase a little bit of labor here. So a lot of capital is going to be reduced while you're increasing labor by only a small amount in order to achieve the same level of output, the same level of utility, right? So firm can reduce, I'm just going to write, they can reduce capital more while increasing labor by a small amount, by a very small amount. And of course, similarly, the B should be kind of the opposite, right? You are reducing labor or capital by just a little bit in order to get a huge increase in our labor, right? So that should say that, okay, the firm would want to reduce capital just a little bit. So reduce a little while increasing labor a lot more. Increasing labor a lot more, right? To achieve the same level of output. So sorry about the handwriting, but this really just tells us, right? The M here, how I'm getting this is just because this slope, this little point, is really saying that MPL over MPK is greater than 1. Right over here, our MPL over MPK, right, that's the dy dx, is less than 1, right? And that slope really just tells us how much capital you're willing to give up for an extra additional unit of output, right? So this stuff really just tells us, oops. These things really just tells us how much capital you give up for extra unit of labor. Okay? And if MPL over MPK is less, like right over here, if less than 1, then you're willing to give up less capital for an extra unit of labor. So that really is just a basic concept of how cost minimization works and what this dy dx or the MPL over MPK really means. But if there's one thing that I want you to get out of all of this, is this formula can be really beneficial as we solve more problems, as you'll see in the next video. So thank you for watching.